Hey everyone, Jason here today with a bit of an unusual project. I am going to attempt to power up the Emerson 580 AM radio. But before we can do that, we have to make ourselves a dim bulb tester. So it'll tell us a few things. I know it's tempting to just plug this in. Not going to do it. So the first thing I'm going to need is a standard light socket. I had this when I was remodeling and renovating a garage. Ceramic. Next thing we're going to need is a light bulb. Not sure of the wattage of this radio, but I have a 75 watt light bulb. This is all the incandescent bulbs I have at the moment, so I need an incandescent bulb. AC outlet. A polarized power cord, although it doesn't matter because the radio doesn't have a polarized cord. Extra piece of wire and a wire nut. So let's get this going here. Let's take a look at the outlet. I was actually surprised I actually had an extra outlet laying around. Let's see here. I'm trying to find which color goes where. I believe the white wire is the flat blade. Sometimes these things tell you, sometimes they don't. Yes. White. So let's get started. So the dim bulb tester does three things. The first thing is, if we turn the radio on while it's plugged into this contraption and the light bulb doesn't light up, we have an open circuit, like a tube filament or something. Next mode is, if we turn the radio on and the light just stays really bright, it means we have a dead short. These old radios usually don't have fuses in them. And the third mode is, if we turn it on and the light bulb is bright, then it goes dim. That means we're drawing current, and that's good news. So that's how these dim bulb testers work. Now also with this channel, channel if I ever decide to make a channel for this, I'm going to do a diary on everything, on how to start up an electronics channel. For somebody like myself who was silly enough to sell off all their repair equipment back when they were in college. I mean, that was kind of silly of me, but you know. And you know, one thing I forgot to bring is a screwdriver. Well, let's just grab one. Let's grab a flat blade, why not? We'll pretend like we're back in the old days. So I'm going to hook the flat blade up to the flat blade of the outlet. Okay. This guy is going to go to here. Now, like I said, this is just quick and dirty. As long as we're not touching the hot and the neutral wire together, we're safe. Let's see here. Yeah, so I'm going to come in here and tie off of this. Actually, this is just going to go into series. We're going to put this here. And this didn't cost me a thing, by the way. I had all this junk laying around. Basically, if this radio does power up and it works somewhat, I'm going to buy me a Variac with all this built in except for the bulb tester. I could have built myself a Variac, but yeah, I'm looking into getting a Syncor PowerRite analyst thing. Because it's got the isolation transformer and stuff. So I'm also, here's the thing though, this doesn't have an isolation transformer obviously, so we got to be extra careful. Because one side of this radio, I believe, is connected directly to the plug. Now I'm usually used to working on smaller solid state stuff, especially stuff that involves PC. Now, one thing I forgot to bring is a pair of needle nose pliers, because I need to bend that wire around. Let me see here. And by the way, I didn't want to drag my camera out in my junky garage, so I'm filming this in the Lego room. Yeah. When I was a teenager, I used to do a lot of my electronic stuff either in the garage or in my bedroom. Well, I thought I had a pair of needle nose pliers. I don't want to have to walk out to the garage and get them. Oh, here we go. So, I hope these are going to be not so crappy. Lately, tools have just been getting where the tools don't last too long. Alright, so we're going to take this, put it to like a J. Boy, these are cheap. What are these? Some name I can't even pronounce. I should have pruned back this insulation a bit more. And my phone's ringing. Well, I'm not going to answer the phone while I'm doing this. Let it ring. It can wait. Oh, this is becoming a pain. Also, when you're cutting, make sure you cut away from you. Don't want to cut towards you because that blade can go in some really crazy directions and you don't want that blade to come at you. Okay. I just have the house spray too. Okay, let me find a pair of pliers. Those are kind of crappy. So yeah, this channel is meant for entertainment purposes, also for maybe some learning purposes too, if you're wanting to start this and you're starting from scratch. I know there's a lot of good YouTubers out there who have done electronics, but they already had their test equipment already established. So, for myself, when I had to get rid of all mine for college, yeah, I have to start all over again. Not too fun. Okay. So, alrighty. Let's get that in there. Well, that was easy. Okay. We're almost done. We're ready to power it up. And yes, I have been shocked before. Mainly because I wasn't watching where I was putting my hands at. So basically we're going to do it like that. And the last connection is going to go on the bottom of the light. Now if the wire doesn't like cooperating, you're going to have to take some needle nose pliers and persuade it. Or just anything that works. Now, why am I going through all this instead of just plugging it in and taking a risk? Well, I'm just not in the mood to take a take a risk today. Okay. That just doesn't want to go in. Really? There we go. We're almost there. Actually, I don't think I needed that wire nut after all. I was thinking of another thing. Well, we'll say that for another job. Okay. So basically, a quick rundown. We have our power. Here's our neutral wire. It goes to the outlet. And we have our hot wire, which goes into the fixture. If the bulb's plugged in, it goes through the outlet. This is going to be our open circuit. The only way this is going to get closed if we plug the radio in or we bridge these 2 points together. So, let's get all this set up. There we go. Not pretty, but, you know, like I said, this is meant for, well, something. Okay, this is why I hate using braided wire. Boy, allergies out here have been pretty bad lately. Alright. Now go in there and behave. You're ruining my TV show. Okay. Maybe that's why I had to get the thing. Well, that just does not want to cooperate. I just need to get this working up to a point so we can test it out. I mean, I just don't want wires flying all over the place. There we go. Now I got it under really good. Okay. We don't care about grounding because this is only a two-pronged system. If I were building this, this would be a lot better. So let's plug it in first, make sure nothing goes pop. Now let's unplug the laptop. Nothing happened. Okay, good. Let's put the light bulb in, and I'm holding the plug so I know it's unplugged. If this turns on, we have a problem. Nope. Okay, good. Now, let's make sure the radio's turned off. We are going to plug in the radio, and hopefully this thing will actually do something. So let's run down through this again. Oh, this is really kind of getting mushy. I don't know which one's neutral. I'm probably going to see if there's a kit or something. I like to modify one of these with a wide blade prong. Alright. Okay. So basically, we have our circuit completed. We turn it on, the light bulb doesn't light up, open circuit. We turn it on, the light bulb is really bright, we have a dead short. Finally, if we turn it on and the light bulb is bright, then it goes dim, well yeah, then we know it's working. Here we go. This is going to take the load. Well, here we go, it's going to go pop. And I am wearing safety glasses, by the way. And sure enough, it doesn't even have any continuity. Could be a flaky power switch or an open tube filament. No sound. Okay. That having been said, there's something open. Alright, so let's unplug all that. All that time wasted, huh? Well, it's not really totally a waste because a lot of electronics guys, they do that. It's also a cheesy way of testing a circuit. Let me go find myself a quarter nut driver. That is an important tool you need in your toolbox when you're doing any kind of electronics work. Is a 1/4 inch nut driver. Alright, let's take a look here. Alright, I think the knobs come off. Oh, this label here fell out of the back. It actually is a Model 580. Alright. Okay. And these are pretty loose, so I'm hoping that's not a bad sign. Plus also it's Bakelite. We can't just tighten these up as tight as we can get them. Screws look original. Now I don't even have a tube tester, so if a tube's bad and here we got an open filament, I can use a voltmeter to test that out. Or oh, I hope that's not cadmium oxide on there. Okay. Alright, let's see here. Alright, let's just slide that out. I'm tempted to pull this, but I'm afraid if I do, I don't want to be ripping out things. Whoa, yeah, look at that. Nice and old school. Oh. Well, let's raise up this handle then. Alright, for those who've probably never seen inside of a tube radio, and There you go. Okay. Well, this is obviously pretty dirty. I bet this thing... Oh, yeah, I did open it up earlier, and I did put some tape inside there to hold the dial glass. So I've already kind of ruined the fun. There's already a problem that I had found already. Remember we were talking about this dial thing here? Maybe there's a reproduction for it. This controls the capacitor. Feels a bit stiff, so I'm not going to force that. So here we have our AM loop speaker. Speaker's not ripped. Doesn't feel like it's rubbing. All right, so let's see if I can get this right here. It's an All-American 5. We have a 35W4 rectifier in here, I can tell. And this must be our IF stage, another IF stage, preamp, amplifier, and rectifier. Now this thing's really dirty, so this obviously was never been serviced. Here we have our incandescent bulb for the display. I didn't notice that. Well, here's the dial cord. So I am going to have to restring this. So we could have a bad power switch, or even one of these tube sockets are faulty. Now when taking out tubes, you gotta be very careful. Just take them and slowly wiggle them out. You don't want to just pull on them, and just slowly pull these out. And these are the micro tubes. These are not the big giant ones. Emerson. Made in USA. Alright, and this is... I can't even read that. I'm going to have to get the service literature. I do have the SAMs though. Oh, this is a 35W4. So this is our rectifier tube right here. Also, the sockets do go bad in some of these too. Now they're also keyed, so you can't plug them in the wrong way like I'm doing. Well, that doesn't feel very assuring. Very loose. I'm checking for loose tubes. See, like this one was really hard to get out. This is made in USA. NU. Never heard of that one. This probably was replaced. So what I'll have to do is check for continuity on each tube. I don't have a tube checker, but I can still test for continuity. Let's pull out the IF. So when I say this is a series strung set, each tube is ran in series like a strand of Christmas tree lights. So if one of these tubes goes bad, it won't like you too much. All right, so let me get this here. Can't remember how to get those out. I think you have to spread them apart. There we go. Of course, we got to have a shield on this because it's the IF stage. There we go. Emerson. 12 BE6. Okay. And we got a IF stage. Now I don't have anything to align these to, so I have to start all over again getting equipment. Let's get that back in there. Put the shield back on because I don't want to lose it. It's just a metal housing that just sits over that. It keeps interference down. The only drawback is it does heat the tubes up a bit more. Reseated the tubes. Now if you really want to see something hardcore, yeah, look at that right there. It's all point-to-point wired together, soldered. Here's our filter cap. We got some paper caps. Those have to be changed. Here's the power switch. This could be flaky. I got to find a voltmeter. I don't know what I did with mine, but I'll have to find it. Just looking for anything loose. So these usually dry out. Now, there's been some thing that, you know, if you change caps, this stuff's going to work brand new again. Well, the stuff back then had a lot of, it had a wider tolerance. Some of these have 10 or whatever percent tolerance. And even the resistors are like that. They're like 10% tolerance. It could be carbon comp. It depends, you know, all that stuff. So even if you replace it with all new components, you're most likely going to have to align it for optimal performance. So now, let's see here. I'm going to try powering this up one more time. Now, since this is broke, well, this is not even bent. I got away with it. The first update, I thought, well, man, this knob is bent. You know, that's not good. Well, it's not bent, but so before I buy any test equipment, I want to see here first if we got a problem with tubes. I could, you know, before I spend all that money on something and finding out it's something else. Yeah, we're gonna do hardcore. We're gonna plug this thing in while we're not here. Let's plug this in first. Now, also, somebody could probably say the bulb's burned out. Well, make sure it's in there really good. I know because it came out of the light that I was using for testing out Lego stuff. Okay, here we go. Nothing. So, it could even be that pilot lamp, although that looks like it's a low voltage, but it could be in series. Well, the next thing we need to do is test out all the tubes and see if we have an open filament, power switch, anything. So yeah, this thing is doesn't work. So yeah, I mean, I can get something modern and plug it into the bulb tester, and I'll show you how that works. Let me get my soldering gun here. So I need to find me a good voltmeter. I'm thinking about getting me a Fluke. I don't know yet. Let's make sure that the bulb tester's working. And I believe that is an original plug. Alright, let's make sure here. And we're going to see if this works. So plug that back in. Let's make sure. See? So there's nothing wrong with the bulb tester. So anyways, that's it for right now. I got to dig out more stuff. So I'm going to put this back together until I can find me a good voltmeter. Because I don't want to lose all the screws and stuff to it. And also, when you're done handling stuff, wash your hands. Because, as a matter of fact, the chassis doesn't even look like it's rusted, but it does have some greenish stuff on there. You know, I'm going to have to clean that off and grease up that chassis a bit. Well, the chassis doesn't look like it's floating either. So anyways, that's it. That's the first look of an inside of a Emerson 580 radio. I'd like to get it working, fully restored. I want to use this. I don't really listen to AM, but it'd be just cool to have and fully functional. Well, until we meet again, I gotta get some more stuff to make this work. So I need to find a voltmeter and test out these tubes, and hopefully we don't have an open filament, because tubes in these are pretty generic. You can probably find these are probably about a couple dollars a piece. Let's say they're about $5. It could cost you, you know, this is an All-American 5. You got 5 tubes. You what, $25, $30 to retube this radio. So also another thing could be is the sockets are bad too. So anyways, yeah, it doesn't work, but we'll probably get it to work someday. I just need to test the tubes out, make sure those are not open. Thanks for watching.